Hey guys, this is Miss Silva, and in this lesson, we're going to review the law of exponents. To be able to be successful today, you're going to have to be able to add exponents using the product of powers, subtract exponents using the quotient of powers, multiply using the power of powers, apply the zero product, apply the zero power, apply the negative exponents, rewrite rational exponents, and then simplify expressions. Let's start with the zero power rule. It tells us that any number to the power of 0 is 1. So a to the 0 power is 1. If that's true, then x to the 0 power is 1. 10 to the 0 power is 1. Anything to the 0 power will be 1. Before we start applying the other rules, we need to be able to rewrite grouped powers. So if we have a fraction that's to the power, that means every number in the numerator gets that exponent and the denominator gets that exponent. For example, we have 3 to the second power and t to the second power. We get 9 over t squared. Same with this one, we'll have the numerator h to the 0 power, and then 2 to the w power. The product of power, if we have a product to a power, then each one of the numbers that are being multiplied inside that parentheses will also get that power. So here we have 2 to the third power times x to the third power times t to the third power. 2 to the third power is 8, x to the third, t to the third. For the next one, we have x to the third and y to the third. When we have rational exponents, we've done this before, where the numerator is the exponent for the radicand and the denominator is the index. So we have t, and it's t to the fourth power, and we're getting the seventh root. And a to the 1/2 power is basically the square root of a, because the power is 1, and then we have an index of 2. Next, we have the product of powers. When multiplying terms, you add the exponents. For example, we have a to the m times a to the n. We add amn, and that will give us our new exponent. Here we have t to the second power plus 4. That gives us t to the sixth power. Here we have y negative 3 plus 6. We have y to the third power. And here, notice how we're multiplying the m's. So we have 2. So we're only going to add these 2. And since the m are the ones that have those exponents, those are the ones we're going to add. So this will look like this. Right now we have a negative exponent, but we will be simplifying it further. We have a quotient of powers. When dividing terms, you subtract your exponent. So let's look at these. We have just x by itself, and then the y's are the ones that we're subtracting. We have y, 3 minus 2. That gives us xy. And there's an exponent of 1, but we don't write it. Next, we have 4 divided by 2. We always want to divide those first. We get 2. And this is where we want to start grouping them. Let's do this example. We group those, we group the W's, and then we have the T. So we divide this, we get 2. We subtract these, we get W negative 2, and then we have the T. When there is a power to a power, you multiply the exponents. this example. So here, each one is going to get to the power of 4. And notice how they all have a power of 1 right now. So 4 times 1 is 4. And then 3 to the 4th power is 81. And then we have d to the 4th, f to the 4th. Now for the next one, notice how we have the 4 on the outside. So that means we're going to be multiplying 4 times each exponent. And that 2 has an exponent of 1. So it's basically 2 to the power of 4. So let's go ahead and rewrite that. We end up with t to the 12th power, f to the 20th power. And t to the 4th power is, so we have 2 to the 4th power is 16, t12, f20. Next, we have the negative exponents rule. When there's a negative power, you flip and switch. Simple. And what I mean by flip is if this number is in the numerator, we flip it to the denominator. And if the number is in the denominator, you flip it to the numerator. For example, a to the negative m power, we bring it to the denominator so it changes to positive. And then if we have a fraction and it's to the negative power, we flip the fraction or we get the reciprocal, and then we turn the exponents positive. Let's look at this one. The exponent is negative. We know that h divided by 1, that h has a denominator of 1. So then we're going to flip it and switch to the positive. Okay, notice how here we have a negative 3 to the whole fraction. So we're going to flip the fraction, put it to a positive power, and then we're going to apply the other rules where each variable will get that exponent. Let's look at this one. This is where we're going to look at each one individually. It doesn't look like any of the variables are the same, so we'll look at them each individually. M is to the positive power, N also has a positive power. D has a negative power, so we're going to move this one to the denominator. T has a positive power. Then we have S has a negative power, so we're going to move that one up to the numerator. And then we're going to leave W in the denominator because it already has a positive power. All right, let's look at practice using all of the exponents. Now, this one, we first want to apply the zero product property. If we have any, there's nothing that is to the power of 0. And then we're going to apply the power rule. And we don't have any power rule, power of power. Usually we want to look for parentheses when we have power of power. Then we're going to group like terms. So we have 2 over 6, those are like, h to the negative 4th, h to the negative 2nd, g to the 12th, and g to the 9th. That's what I mean by grouping. We're going to apply the product rule. There is no product rule. That's when they're right next to each other. Applying the quotient rule. This one we have plenty of quotient rules, and our rule tells us that we need to subtract. So let's go ahead and divide these just like normal numbers. We have to divide it by 6, will give us 1/3. And then we have h to the negative 4th divided by h to the negative 2nd. For this one, we're going to subtract. So we basically have x negative 4 minus negative 7. Then we're going to do the same thing to the g, and here we have g 12 minus 9. So let's go ahead and simplify that. Negative 4, whenever there's two negatives, we add them. So negative 4 plus 7 is h to the 3rd. And then we have G2, 12 minus 9 is 3. So that is our simplified expression. Notice how at the very bottom, we want to go back and check for any zero product rules. And at the very end, you want to look for negative exponents. After we subtracted, we no longer have negative exponents. So that is our simplified expression. Okay, let's go ahead and try this one. Hit pause, try it on your own and see if you got the correct answer. An exponent on the outside, that means each one will get that exponent. And if it already has an exponent or an exponent greater than 1, we need to multiply them. So here we have 5 to the 4th, and then we have x times 4. 3 times 4 is 12, so we get x to the 12th power. This one doesn't have an exponent other than 1, so we really just have to write it again. All right, so from here, we want to group our, so now we're going to group like terms. So here are all our numbers that we're going to group together. So that's 5 to the 4th times 9 divided by 3. And then all of my x's are also alike. So we're going to put those x12, x2, and x15. Okay, we're going to do 5 to the 4th power. Divide by 3. And get 1,875. And then we're going to apply our product rule here where we're going to add them. So that gives us 14. And then we're going to use our quotient rule, which tells us we're going to subtract. So this is really 14 minus 15. That gives us x to the negative first power. That any whole number has a denominator of 1. So we're going to move this one to the bottom. And we don't have to write the 1. So here's our simplified expression. Okay, let's look at the next one. We have parentheses, so we're going to multiply these two. Notice how the 2 is not inside of the parentheses, so we don't put that 4, exponent of 4 with a 2. So this is going to give us a to the negative 8th power. All right, there's no zeros, so let's group our like terms. It's just 6 times 2. And then we're going to group all of the a's together. So a to the 8th, a to the negative 8th. Then we got our b's. We have b to the 7th. In the numerator and the denominator, negative 3 and b. Okay, so let's simplify this. We've got 12. 8 minus 8 is 0, so a to the 0 power. And then we have a 1 over here, so we're going to add these two. That gives us negative 2. And so we have b to the negative 2 as the denominator and b to the 7th as the numerator. So these we're going to subtract. So 7 minus negative 2. Remember, when you have two negatives, we turn it into a positive. So 7 plus 2 is 9. So we get b to the 9th power. We apply the 0 rule. And that tells us anything to the 0 power is 1. So we can basically cancel it because 12 times 1 is 12. So 12b to the 9th power. Okay, go ahead and try this one. Push pause and then come back and see if you got the right answer. All right, here is the answer.